Okay, so hello everyone, good afternoon. I think I'm audible and visible to all of you. Please confirm, guys, if I'm audible and visible. So, good evening, sir. Yeah, good evening, good afternoon, everyone. It's good. So, yeah, last week I was not able to take a class because of like a family emergency. But yeah, this week we have a class. Sometime it happens. So, shall we start, guys? Yeah, everyone. And I have seen many of you have already completed your, assignment, which was amazing. Most of you were able to, host your API, and yeah, so it looks great. So when people do an assignment, looking great in explaining. Thank you. Okay, so what is a topic we are going to discuss this week, guys? Any idea? Yes, any idea, guys? Okay, so Vector DB. Ravi is saying today I joined, sir. Not an issue, Ravi. So you will be able to cope up. So yes, as everyone is saying that we are going to discuss, we are going to talk about a vector database. So yes, we are going to talk about a vector DB. But before starting with a vector database, so anyone who can tell me why do we need a vector database? We have already seen a SQL DB, right? So where we can try to store our data in a tabular format, in a structured format. And we have even seen a MongoDB, so where we can try to store a data in a form of document, a JSON precisely, but yeah, it's called as document. So we have a NoSQL based, not only SQL based database, and we have a SQL based database. And then we are going to talk about DB, vector based database. So any idea what is the significance of this vector database? What kind of a role vector DB is going to play? What kind of a data we are going to store inside a vector database? Any idea, guys? So Kunal is saying for a fast query or a semantic search. Imtiaz is saying semantic search, not exact matching. Okay, to a store embedding data, fine. Prakash is saying unstructured data. Prakhar is saying semantic search. Okay, okay, converting text into a numeric. Text, image, video like data. Text, image, video like data. I can try to store it even inside like a other databases or maybe into a file system. That is also possible. We have been doing that, right, since a very very long time. So it's nothing new to store, text, image, or maybe a video based database data set basically. Tokenization, okay, fine. Semantic search, okay, okay. So most of you are giving me exact like accurate result, like accurate answer, I would say. Okay. So when we say a vector embedding, so anyone who is having any kind of understanding about vector embedding? Yeah. Any idea, guys? What is a vector embedding? Array like numerical representation. Okay, fine. So those who is having some sort of idea, it's completely fine. Those who is not having any kind of idea, that's also fine for me because this is what I'm going to teach you. This is what I'm going to explain you that why we are going to use a vector database and how we are going to store what and all kind of a database which is available in a market, which we are going to use. What is a comparison between these vector DB? And this class for a vector DB is going to be a little bit longer. So it's not like I'm going to complete the entire vector DB in today's class itself. Syllabus is a bit bigger. So obviously we'll try to understand each and everything in a step-by-step manner, and we'll try to understand because we have to use this vector databases. We have to use these embeddings throughout our entire session as a part of this generative AI lecture. Not just that, I would say, so whatever application that we are going to build going forward, everywhere you will end up using this kind of a data set and this kind of a DB. So it's pretty much important for anyone and everyone who would like to build any kind of a generative AI application. Without that, it's, I will not say impossible, but yeah. Uh, close to like impossible to build any kind of a production grade system without having understanding or without having a knowledge about these kind of a databases. And that is the reason, so this lecture comes in a very very first part of your entire syllabus. Yeah, morning to evening looks is changing. Yeah. Okay. Fine, let's get started then. So here, let me use a new page. So basically, guys, see. So whenever we are talking about a data set in terms of a generative AI application, right? For example, let's talk about just LLMs, large language models. So we all know that we have a large language model like Chat GPT, we have a Gemini, we have a Llama, we have basically a Mistral, we have a DeepSeek. So many large language models are available. And what we do, so generally we try to chat with those models, and those models are going to generate some sort of a data based on my chat, technically a prompt, right? So we try to give input as a prompt, and then based on my prompt, system or these LLMs, large language model, is going to generate some sort of a data, and then it is going to give it to me. And this is what and this is how we have been using Chat GPT, we have been using a Mistral, we have been using Llama, or all the other LLMs. So technically, these models are basically a generative model. It generates a data, means it is going to give you output as a data based on the input, based on the prompt that you are going to give. Now, so all of these generative model that we are talking about, so technically these models are nothing but a set of neural network, right? Eventually it's a transformer, so it is based out of the transformer architecture. But if I'll talk about building blocks, so building block of all of these models are, or even for transformer, it's a neural network. And neural network is going to do some sort of a computation, it is going to understand your entire input, and plus it is able to understand data on which it has been trained, and eventually it is going to give you the output. And the problem with our computer system is that it is not going to do any kind of a calculation, it is not going to do any kind of a computation with respect to my kind of a input, means NL, a natural language, right? So we always try to give a command, we try to give an instruction with respect to a natural language in our own language, maybe English, maybe Hindi, Tamil, Telugu, Punjabi, Bengali, or maybe Spanish or French. So we try to give a command, we try to give an input by using a natural language. And computer just understands numerics, and specifically binary 0 and 1. So eventually it is supposed to convert my textual information, my text data, into a numeric, and then on a very low level those numerics will be converted into 0 1, and then calculation or computation is going to happen, right? Calculation and computation is going to happen. So whatever data we are going to pass, for example, so if I'm trying to pass something like my name is Sudhanshu. So computer will not be able to understand this entire sentence. Computer will not be able to understand even a relationship between my name is Sudhanshu, maybe in a forward order, maybe into a reverse order, or maybe on a attention wise order. It will never be able to understand it. So what it does, so at the time of training, so whenever we are going to train a model, so it is going to convert this entire data set into its numerical representation. So numerical representation. So it is going to convert this entire data in a form of array basically. So where I will be having a numbers, some sort of a numbers I will be having. And then based on these numbers, based on other sentences that we are going to pass, or based on other corpuses that we are going to pass, it will try to understand a relation. So basically this entire data will go into a neural network, it will try to understand a relationship in between, it will try to adjust a weights of an entire neural network, and eventually it will be able to yield a result. This is what happens, right, with respect to any neural network. So anyone who is not having any idea about neural network computation, anyone? No idea at all, means what is a neural network, how data input happens, what is the meaning of forward propagation, what is the meaning of a backward propagation, how it is going to optimize a loss over there, what is the meaning of a optimizer function, what is the meaning of a loss function. Yeah, Okay, so Astos is saying no idea, Pramu is saying no idea, Rakesh saying have some idea. Okay, so I'll strongly recommend you, right? Those who is not having any idea about a neural network, right? Not at all. So I'll strongly recommend you to go through couple of my lectures, maybe not today, for not for today's class. It's completely fine. I'll make you understand even without that understanding. But strongly I will recommend you, because with respect to a complete mathematical explanation, right, and a relationship, so I have explained each and everything about a neural network and about a training. So how training actually happens, how neural network actually going to work, each and everything inside this particular class. So neural network introduction, then neural network continued, then CNN, RNN. So all of these things are already explained inside your FSDS lectures. So try to spend some time, right, so that you all will be able to understand a core philosophy behind a neural network, a core mathematics behind a neural network, each and every component of a neural network, because believe me, that is going to help you out, not just in this lecture, right, but throughout your life. Because in a world of natural language, NLP, right, in a world of computer vision, in a world of deep learning, these components are pretty much required, and this is going to help you out in a long term as well to understand any kind of a upcoming neural network which people are going to release in a market, right? Plus, I have also talked about attention is all you need, which is nothing but a transformer. So here you will be able to find out a transformer lecture. We have also built our own small chat GPT from a scratch, right? So in this particular lecture, so maybe you can try to go through couple of lecture. So whatever lecture in which you are going to get some sort of a interest, just try to go through it, and maybe in your free time, next week, next to next week. But yes, it's strongly recommended, highly recommended to all of you to go through a entire neural network concept. Those lectures are already available inside a platform again. So these lectures are available even in other classes, but yeah, so maybe you can go through this, and that will be more than sufficient to understand and to give you a in depth, in detail clarity about a neural network. Now, so because everything is not possible to discuss in one single lecture, that's the reason. So we have a lot of classes, because syllabus itself is very very big, and we have to talk about each and everything, and I have to help you out in terms of understanding everything. So please go through that one. It's a FSDS lecture, full stack data science. Just go and search with the name FSDS, and obviously you have all the access of each and every lecture, so you will be able to get it. Okay. So here, coming back to our main concept, embedding and vectors, basically. So here, what we do, so we try to take these sentences, eventually we try to convert that into a numerical representation, and this numerical representation is called as vector, right? This numerical representation is called as vector with n dimension. So every vector will be having a particular dimension. Meaning is what? So let's suppose if I have this sentence, right? If I have this particular sentence. Now, if I would like to represent this particular sentence maybe into a two-dimensional space, right? Two-dimensional space. Let's suppose this sentence is been represented over here. This is my x-axis and this is my y-axis. So can I say that I'm trying to represent this yellow dot, the dot that you are able to see, in a two-dimension? Yeah, in a two-dimension I'm trying to represent it. So if I'm trying to represent this dot in a two dimension, so obviously I will be having a x coordinate as well as I will be having a y coordinate. So I will be having x coordinate and I will be having a y coordinate. So let's suppose x dash and y dash in two dimension if I'm trying to represent this particular dot. Now, so this is called as vector because it will be having a magnitude. So magnitude in terms of x and y. So it is having a x value as well as it is having a y value, right? It is having a x value as well as it is having a y value. And as well as it is having a direction, means it is having a representation in a particular space. Now similarly, so if I'm going to increase a number of dimension, yeah, if I'm going to increase a number of dimension, so maybe I will end up representing a particular vector by using three coordinates. So maybe this is the dot, but this dot will be having x axis, y axis, and maybe this will be having my z axis as well. So maybe x, maybe y, or maybe z axis, and this dot will be represented by three coordinate, maybe x dash, y dash, and z dash. So this is again, this is called as vector. Yeah, vector. So this is basically my 2D vector. Yeah, two-dimensional vector. This I can say as a three-dimensional vector. Now I can try to even create a 4 dimension, 5 dimension, 6 dimension, 1000 dimension, 10,000 dimension. That is possible, right? That is possible. I will not be able to visualize it because max to max visualization wise, I will be able to do a visualization in a 3D, even with the help of programming or even in real life. So we all are living in a 3D space, by the way, right? Me sitting over here. So obviously, my like a entire body will be having coordinates, right? So x coordinate, y coordinate, and z coordinate. Even in a room where you are sitting or whatever object that you are holding, every object will be having a like a particular coordinates, right? And with the help of particular coordinate, you will be able to represent, right? You all will be able to represent, and that coordinate will be having a direction. So you can simply say that okay, move this much 1 centimeter, 1 meter, or 1 kilometer, or maybe something from here to here in x direction, and then go in y direction, then go in z direction, and you will be able to find out a particular object. This is the meaning of vector, by the way. So vector simply means that a kind of an entity which will be having magnitude as well as dimension. Magnitude is nothing but a coordinate values, right? Coordinate values. And direction is nothing but, so when you are going to combine each and everything, you will be able to locate that particular point, one single point, one single dot, you all will be able to represent. So here we have a 2D coordinate, here we have a 3D coordinate, right? Here we have a 2D coordinate, here we have a 3D coordinate. So technically it is possible, right? Technically it is possible that if I have some sentence in my hand, for example, my name is Danshu, right? And if I would like to represent this in a numerical coordinate, with the help of numerical coordinate, I will be having x and y value for this representation of the sentence. If I'm going to represent this in a 3D coordinate, I will be having 3 values, x value, y value, and z value, to represent this particular sentence. Yeah, to represent this particular sentence. Likewise, so if I would like to represent this in maybe 100 dimension, so in that situation, I will be having 100 coordinates, right? 100 coordinates, and that 100 coordinates altogether will try to represent this entire sentence. Means same sentence I am going to represent with the help of hundreds of the coordinates. Similarly, so I can try to use 1000 coordinates, I can try to use 4000 coordinates, depends upon the architecture which I am going to design. Now, why I am again and again talking about these coordinates, a 2 coordinate, 3 coordinate, 5 coordinate, 100 coordinate, 1000 coordinates? Because as your number of coordinates is going to increase, right? As your number of coordinates are going to increase, so for sure the explanation of the data, I would say, right, or representation of the data will increase. Means you will be having more numeric value, so that you will be able to build more relation, or it will be able to explain, or it will be able to register more relation in between the data. That's the reason we say that always try to take higher dimension. So whenever we are going to create a vectors, or wherever we are going to create a embeddings, especially for a natural language, always go ahead with the higher coordinates or higher dimension, so that in a high dimension, representation or relation will be more, right? More. Yeah, more overhead also. But yes, there is a trade-off, right? There is a trade-off of each and everything. So obviously, if I'm talking about a natural language, in that case, I had to take that overhead. Yeah. So vector is equal to magnitude plus direction. Exactly. That is the meaning of vector. So if I'm going to say 1, right? If I'm saying 1, maybe 1 unit, 1 meter, 1 centimeter, 1 inches, or maybe 1 of anything, 1 unit. It simply means that it is a scalar entity. It's not a vector. It's a scalar entity. So a scalar means only magnitude, right? Scalar means only magnitude, but vector means a particular coordinate, and coordinate will be having obviously x, y, z, and then beyond, like a direction, as well as it will be having a particular value of that particular coordinate, which will be represented by one single dot, right? Which will be represented by one single dot. So here, so why we are talking about this vector, why we are talking about this embedding? Again, coming back to the same question, right, that we have already started, that we have initiated. So here we have a sentence. We are dealing with a natural language. Yeah, natural language. And obviously, natural language is nothing, it's not just a representation of a word, or it's a combination of the word. Technically, it's a relationship, a grammatical relationship or punctuation, all of those things we are trying to build, because in a particular sentence there will be some noun, there will be some pronoun, there will be some verb, adjective, adverb, and many more things which will comes in between. So obviously, if I have to represent a sentence, I need as high dimension or as high coordinate as possible, so that that values will be able to represent somewhere a complete meaning of this particular sentence. Maybe some is going to represent just an arrangement, some is going to represent a relationship, some is going to represent which is going to come before, which is going to come after, some is going to represent a semantic meaning, some is going to understand, or it is going to represent a syntactic understanding. As simple as that, right? So this is the reason. So we always need a vector. Just with the help of one single number, scalar, I will not be able to represent. We need a vector. We need a vector with a very, very high dimension. So whenever you chat with a chat GPT, right? Whenever you chat with a chat GPT, what happens? So let's suppose if I'm going to enter some sort of a prompt that, okay, give me like a, today's news, for example. So it is going to convert your natural language. Eventually, it is going to convert your natural NL basically into a vector, into an embeddings. And that embeddings, that vector go as an input inside your neural network. For example, so let's suppose I'm going to represent a very simple neural network over here, right? Very simple neural network over here. So my name is Sudhanshu. So I think I need just like a 4 for now as per my data. And then we have some sort of a hidden layer, and then we have a output layer, and all of these neural network neurons are connected to each other, let's say. Fine. Okay. So here, in a layman manner, again, this is not exactly how it is going to happen, but just for the understanding purpose, I'm trying to draw. So let's suppose this is my neural network, right? And I have a sentence in my hand. My name is Sudhanshu. This is the kind of a sentence. So what I will do, I can't pass this, alphabets or this kind of tokens, or I would say this kind of words inside a neural network, because neural network is nothing but it's a mathematical model, right? It will not be able to understand. So what I will do, I'll try to maybe convert this one, this one, this one, this one into its numerical representation. So eventually I will try to convert that into a vector, and then I'm going to pass its value. And obviously inside that there will be a weights. With that it is going to do a calculation. There will be activation functions. There will be output functions. And finally, I will be able to get the output. Now, so whenever you chat with LLMs, right? Whenever you try to chat with the LLMs. So similarly, what it does, so it try to convert your input, your prompt into a numerical representation. It sends inside a LLMs, which is nothing but a model. Model is nothing but a neural network, and eventually it's a transformer based neural network. So where your entire data will go, it will try to do all the calculation, and then eventually it will try to give you the output, and that is the kind of output you all are able to see, right? You all are able to see. Now, so here it so basically it is out of curiosity, maybe you must be having a lot of questions over here, that how it is able to convert into a numerics, part number one. How it is able to understand those like the numeric which it is trying to convert into. So why it is trying to convert into that kind of a numeric itself, how calculation is going to happen in between a neural network, how I will be able to get a final output. So there must be a lot of questions if you are not aware about a neural network concept, and that is the reason so I have advised you that please try to go through those neural network lecture, which is going to give you a very, very clear mathematical understanding. So even just by using pen and pencil, pen and paper, you will be able to do a calculation, especially with the small neural network, not with the big one, right? Because as the layer of neural network, input size of the neural network, output of the neural network is going to change, the complexity of those mathematical equation is going to increase. But yeah, with the small neural network, you all will be able to do a calculation in a beautiful manner. I have already explained that particular part. The whole idea is that whenever we are trying to pass any kind of a sentence, we have to convert that into embeddings, or eventually it's called as a vector. And then it will go through a network and it will be able to get the output. As simple as that. Now, so during your entire lecture, so whenever you are going to pass a data, whenever you are going to use a LLM model, you will end up doing exact same thing. Now, here we are talking about a vector DB, vector database. So what it does, by the way, so it will try to store this vector, a numeric representation of a particular sentence or particular natural language. It is going to store inside a database. So far, so forth, like I said, so we have been storing a data into a tabular format. So where we try to design a schema, and schema means a column we try to design a relationship, and then we try to store a data, or maybe in a form of document as a key value pair. So we try to store a data, or maybe in a form of a graph we try to store a data. There are other formats as well, right? So yeah, these are the popular format in which we try to store a data, and we try to store the exact data, right? Exact data. So whatever data that we are passing. But here, so what we are trying to store inside a vector database, so we are not trying to store the exact data. Obviously, we are going to store exact data as well. But the major part is that we are going to store our data in a numerical format after converting those data. How we'll be talking about it? How we are going to convert those data into a numeric, into a embedding format? We'll be talking about that. I'll show you even a practical example today itself, right? But this is where this vector database comes into a picture to store those data set. Now, what is the use? Let's suppose I'm able to store this data, right? Let's suppose I'm able to store my name is Nanshu into a numeric representation, into a form of vector inside my vector DB. Where I'm going to use it? What is the purpose of storing those data? Any idea, guys? Any idea? So what is the purpose of storing this data? Why we are even storing those data into a vector DB? Is it related to TF-IDF? So TF-IDF is one of the way to convert your data into a vector. Yeah. Two embeddings and compare. Yeah, embedding we are going to store. Embedding means vector actually. So to retrieve our data when generating the content. Okay. But let's suppose, okay, so here Venkatesh has told me that to retrieve our data, right? He told me that to retrieve our data when we will try to generate a content. But let's suppose if I'm going to use a chat GPT, I can try to, like a call over here, and I'm going to say that, okay, fine, so give me this idea. So I have already given a prompt and it will start generating some sort of a data. So even without storing anything, I'm able to generate a data, right? Without storing anything. I have not stored anything over here, but still I'm able to generate the data. Still I'm able to chat with Chat GPT, Gemini, or any other model. Yeah. By the way, Gemini model is available in a WhatsApp Yuri. So you will be able to use it, and you will be able to even generate images with the help of VO3. It's already available in a Yuri AI WhatsApp mode. Okay, so to retrieve the data when generating the content, no. So Prakhar is saying do sine. Okay, I think you are saying do cosine similarity and similarity search and retrieve of the information. But why? That is my question. Is embedding and vector both are same? Yeah, embedding is nothing but a representation. Vector philosophically, or I can say like a definition wise, vector is nothing but a kind of a data. This is the definition of vector. Vector means a kind of a data which will be having magnitude as well as direction. That is actually called as vector as per its mathematical definition. When you try to convert your sentence into a vector, it's called as embeddings. Yeah. Okay. So I think you are able to get your answer, Soumya. Yeah. So Prakhar is saying cosine similarity. Okay, cosine similarity is one of the way to check like a relationship in between. For semantic search, context understanding by the model, I mean when we prompt, we can compare. Okay, for training the model, no, not for that. See, guys, my question was very simple. Why do we need a vector database? That was my question. Yeah. So why we are storing those vector, or technically embeddings, right? Embeddings are nothing but a vector, right? So why we are storing those embeddings, why we are storing those vectors inside a database. If your answer is to generate some answer or some output, then even without storing it, I'm able to generate the output. Even without storing it, the entire world is able to chat with all those models, all those LLM models. So Viva is saying retrieve the similar data of our prompt from a vector database. Yes, that's true. To understand context and identify the nearest word. That's again true. In short, we want to store the data. Okay. To create a pattern for the future. Okay, I'll give you one example. Yeah, so that you all will be able to understand what is a purpose. What is a purpose behind storing a data into a database? A practical, a real-time purpose. And this is something that we are going to build, right? So we are going to fulfill that purpose and we are going to build such kind of a system. I think in like a next 2 or 3 class, maybe by next week, we will be able to build and we will be able to deploy those kind of a solution, which is going to be very, very useful one. So see, I'm able to chat with ChatGPT. Yeah, I'm able to chat with ChatGPT. It is able to give me an answer. Obviously, every LLM, whatever LLM that we are going to use, it will be having some deadlines with respect to our knowledge because it will be trained till a particular date. And again, so we have a web search feature as well. So it will go to web, it will try to scrap the data, it will try to summarize it, it will try to give it to you for a real time search. But let's suppose you are going to ask a question. Yeah, you are going to ask a question to a chat GPT that what is the HR policy for taking a leave in your organization? Again, just try to listen up my question first. If you are going to ask a question to a chat GPT, Gemini, or any models out there, that what is a leave policy for my what is the HR policy for taking a leave? Is it going to give you an answer? Chat GPT is going to give you an answer. Will you be able to get an answer from a chat GPT? No, right? Let's suppose you have some sort of a like a insurance company, so who try to sell a lot of different kind of a insurance, maybe a health insurance, maybe a personal insurance, maybe like some sort of a car insurance, or there are lot of other insurance as well. If someone would like to, right, let's suppose you are trying to build a chat bot, you are trying to build a bot, and that bot is supposed to serve a customer based on the customer query, and customer is going to ask a question with respect to your insurance document. Now if you are going to integrate chat gpt, will it be able to answer, will it be able to give a exact answer with respect to your insurance document, your insurance policy? Again, no. Are you able to understand, right, a problem statement that we are talking about? Yes, everyone. So with respect to my personal data, anything and everything that we are trying to build, so with respect to my personal data, chat gpt, or maybe a llama, maybe a mistral, maybe a deepseek, maybe a gemini, maybe a cloud sonnet, maybe opus, maybe haiku, any of this model will not be able to give an answer, not even close to it, right? Because it is not having my data access. My data is a private to me, right? My data is private to me. So system will not be able to give an answer with respect to my data set, and that's a problem, right? If I have to build a solution for my organization, for my customer, for my people, for example, right, for example, so here I'll show you a practical example here, right? So we have a Yuri WhatsApp. Now if I'm going to ask a question that tell me a latest course launch, yeah, so I'm just going to ask this question to Yuri. Now, so again, it is not going to ask this to chat gpt, right? It is able to give me an answer that this was a latest course launch, Azure plus Databricks data engineering. And yeah, so you can even talk about a lectures, you can even ask about a lectures going forward. Very soon we are going to like integrate a system, so we have like a build those systems, so we are like going to integrate, we are going to release it, where you will be able to ask a particular topic. And let's suppose I have taken a 2 hour of lectures, and in many lectures I have discussed those topics, right? Maybe for 5 minutes, maybe for 10 minutes. So this URI AI that we are building, so it will be able to extract all of those class URL. It will be even able to tell you that out of this 2 hour of lecture, this particular topic that you are talking about is discussed at this timestamp to this particular timestamp, right? So obviously, ChatGPT or any other LLM model will not be able to give an answer with respect to your private data, right? With respect to your private data. So if you have to build such kind of a system, yeah, if you have to build such kind of a system, what should be my approach? So if I have to build such kind of a system, my approach should be to store my information, store my data set into some of the database. First of all, right? So generally, this was the whole idea, right? This was the whole purpose behind using this SQL based database, or maybe a no SQL based database, right? We have been using it since our ages, since a decade. We all have been using it. Without database, none of the system in this entire world is going to work, where we try to store our data. Now you click, it try to retrieve the data. You fire a SQL command, it try to retrieve our data, right? A NoSQL command with respect to a DB. It retrieves a particular data set. Now here, so when we have like a a data set available in a form of document, in a form of image, in a form of maybe video, in a form of maybe audio, right? In a form of maybe like text transcript or something, right? Or maybe a PDF document, a huge one. So I have to, so if someone is going to ask a question, again, same question, right? What is the HR policy to take a leave? Yes. Tell me like a price of this particular kind of insurance. What will be the benefit I will be able to get out of this insurance? So whether this insurance plan or policy is going to cover this or not. So what it is supposed to do? It is supposed to go into that document, try to retrieve all the required information. So whatever information is closer to my prompt or closer to my natural language, right? Because everyone is going to ask a question in their own way. Again, coming to a next problem, by the way, right? So whenever I have to fire, or whenever I have to extract some sort of data from a SQL databases, can I say that people have already designed a programming language for that? Yeah, that we have been using since many decades, I believe. Yes. So in terms of a SQL database, if I have to extract a data, right? If I have to extract a data, I have to write a SQL query, right? Again, in case of MongoDB, in case of Cassandra, in case of a HBase, in case of a Neo4j, in case of a InfluxDB, in case of a BigQuery table, for every database, there is a language which has been defined. There is a syntax which has been defined that, okay, so you have to extract this data, then you have to write a syntax in that way. Then only it will be able to extract a data, right? Extract a data. But after this LLM models, yes, after this LLM model, so how we are trying to command? Yes, guys, how we are trying to command a system? How we are writing a query? Can I say that we are trying to command, we are trying to like write a query just in my own language, in my own wordings, by using my own grammatical things, by making a lot of mistakes during writing entire sentences? Yes, in a natural language, right? In a natural language, we are trying to query that data, right? We are not writing a SQL. We are not writing some sort of a NoSQL or any other like a programming language. We are not using it, right? We are not trying to retrieve our data in that manner. So we are trying to command a system by using a natural language. So I simply say that okay, tell me about this policy. They simply say that okay, so what is a leave policy? So what if I'm going to take a leave for 5 days? What kind of a document I'll have to submit as per my HR policy, right? So we are trying to write a query. We are trying to give a command by using our own language. And all of us, right? If we are chatting to a same system, exact same system, we will go and we will chat in our own way by using our own wordings, by using our own semantic and syntactic combination, right? So we need a system, we need a database, right? We need a database where That database should give me a response. That database should give me a data back to me, not based on the SQL syntaxes or not based on NoSQL, because both is following the syntaxes only, right? So it should be able to give me, right? It should be able to give me a response. It should be able to give me a return based on my natural language. And how it is possible? Any idea? So are you able to understand the problem statement, guys? So where we are moving? So why we are not using SQL DB? Why we are not using NoSQL DB? Why we are moving towards a vector DB? What is a problem that we have and that we are trying to solve? Yeah. So let's suppose if I have to like give a command, because everyone is not going to write, or no one is going to write basically a query, right? Because everyone is not a programming expert. So let's suppose there are like some normal customer associated with the HR, associated with the insurance company. So obviously they are going to ask a question in their own way, and system is supposed to give a response, right? Then can I say that whenever, let's suppose, whenever there is a customer, so customer versus system interaction, so whenever customer is going to ask about tell me about XYG, maybe like a policy or maybe a document. Now same sentence people can like frame in a different manner, and then this should go to a system, right? This will go to a system. Now obviously when this sentence will go into a system means DB I'm talking about, so database I'm talking about. So obviously I'm not writing a SQL NoSQL kind of a query or a proper well structured predefined syntaxes I'm not using over here. It's just a, in a layman manner, I'm going to ask a question. So can I say that I need a database over here, right? I need a database over here. So which should be able to, or which must be, I would say, right? Which must be able to do a comparison between this sentence and all the sentences which is available inside this DB, and it should give me a result whichever is closer to this query. Can I say that? Can I say that if I have to retrieve an information, right, just based out of a natural language, so I need a kind of a system which will be able to check which is the nearest answer available inside my DB, which is, let's suppose there are thousands of like a lines which is available as of now, right? Thousands of lines are available. Going forward, we'll say document, but yeah, thousands of lines are available. So it is supposed to check which line is going to be a nearest one, and it should give that as a final answer. Yes, it should give that as a final answer. How that will be possible, by the way? Yeah, how that will be possible? So basically here, let's suppose we have two coordinates, right? We have two coordinates. Let's suppose we have two dots. Yeah, 2D coordinate, let's suppose I'm talking about. Now here we have 5 comma 6 and then 1 comma 2. If I'm going to ask you a question that what is a distance between these two coordinates? Yes, what is the distance between these two coordinates, guys? I think we all have done that, right? In a class 8th or 9th or maybe 7th. So we have two coordinates, by the way. Let's say A and B. Someone is saying Manhattan distance. I mean, like, let's talk about Euclidean distance first. Yeah. Okay. So let's suppose if I'm talking about if I'm asking you that, okay, tell me what is distance between these two. And then there is a third point. So let's suppose a point number C, and here, so it is available at 0 comma 2. There is a point maybe a D, and here, so coordinate is 1 comma 4. Randomly I have given those coordinates, so there is a D. Now if I'm going to ask you that what is a distance between A and B, so can I say that Euclidean distance, again there is something called as Euclidean distance, there is something called as Manhattan distance, there is something called as cosine similarity, there is something called as IP. So there are other different ways to find out the different distances and relevancy. But as of now, based on our childhood understanding, I'm just going to talk about this. So let's suppose if I'm asking you a question that tell me what is the distance between A and B. So fine, you will say that distance between A and B is nothing but root of 5 minus 1 square plus 6 minus 2 square. So 5 minus 1 is going to be like a 4, 4 square is going to be 16, and then 6 minus 2 is 4, 4 square is going to be 16, 16 plus 16 is equals to 32. So it's a root of 32. That is the distance between A and B. Fine, that is the distance between A and B. Now let's suppose A is representing your customer query. A is representing for now a customer query. Now, you have A, which is representing a customer query. I'm going to mark it as red. And this B, C, and D is representing a sentence which is available inside your system, inside your database. Fine. This is a representation into a 2D coordinate I'm talking about, just a 2D coordinate, right? Now, if I'm going to ask you a next question, that tell me which one is nearest to A. Tell me which one is nearest to A. So can I say that you are going to find out distance of A and then C, then distance of A and D, and then you will be able to give me the answer that which one is nearest to A. So A is nothing but my customer query, and then B, C, and D is available inside my system. So okay, I will be able to do a math over here. So 5 minus 1, so which is going to be 4, 4 square is going to be 16, plus 6 minus 4, 2, and 2 square is going to be 4. So it's a root of 20. Now, A and C, sorry, I have done calculation for A and D. Let's do A and C calculation over here. So 5 minus 0, 5, so which is going to be 25 square wise, and 6 minus 2 is going to be 4, so 16. So 16 and 25 is going to be 41. Yeah. Now, A was your customer query, and you have three sentences B, C, and D. Now tell me which one system is going to return if user is going to ask a query. Which one, which like as a top one, right? So which one system is supposed to return? I believe we all have the answer. Yeah. So which is the nearest one with respect to A D part. So D sentence available inside my database, D sentence available inside my database is the closest one as compared to what? As compared to this particular input, sentence input which I'm trying to give. Yeah, sentence input I'm trying to give. Now, this is where we are talking about embeddings or vectors. What do we do? So we try to convert this entire data into a numerical representation, even if it is a query. And whenever we are trying to store a data inside a vector database, by default, it is going to store it in what? In a vector numerical representation, right? Which is basically called as embeddings. And then what we do? So we try to, find out some sort of a distances. There are different kind of a distance. I'll be talking about that, right? So we try to check the distances, and based on that, it is going to give you the nearest one, or we say top K, top N, top the nearest one, right? So top 5, top 2, top 3, something like that, depends upon the configuration. So it is going to give it to me. So can I say that in this manner, yeah, in this manner, I will be able to solve a problem in my hand. And what was the problem? The problem was to generate an output from my private data. Can I say that I will be able to solve that problem? Yes, generate a output based out of my private data. Now you will say that okay, you are able to generate a output based on your private data. That's okay. That's completely fine. Then where do we need these LLMs? Or do we we don't need even LLMs? Yes. So LLMs can also do it right by uploading a PDFs. Yeah, that's true. I'll come to that particular point as well. So based on the context, based on the memory. So yes, it does that. It is going to do a summarization. You can ask any kind of a question with respect to LLMs nowadays. But let's suppose I have a 10 GB of a data. Will you be able to upload 10 GB of data in ChatGPT prompt itself? You can try that out because they have a limitation of a data upload. Even Cloud A. Yeah. So will you be able to upload 10 GB of a data? with every chat, right? So let's suppose you have like, are you okay? That is a question number one. Question number two, I was talking about insurance kind of a system. So where your customer is going to ask, right? So are you trying to propose that every time customer will come and they will try to upload a data, customer will not be having your data set, right? Or your files, basically, where you have mentioned all the policies. Or are you trying to propose that from your end itself, from server side itself, you are just going to give access of the file, and then in real time it should go through all the files, 10 GB or 20 GB of file, maybe petabyte of files? Practically not possible, right? Yeah, that's a problem again. This is where we are using database, right? So we have a in-memory database as well, SQLite kind of a databases. So where we, like, wherever we have to store like a data in a lightweight manner. So obviously we have been using SQL databases since ages, right? But yeah, we have like a lot of like a SQL based database where we try to like host a terabyte and petabyte and zettabyte of the data. That kind of a database also we have. This has been used across the entire industry. So here, the major problem that we had in our hand to build a kind of a solution, right? So to build a kind of a solution, so where I can store my entire private record. I have zettabyte, petabyte of my private record. So I can store all of those record in a form of what? In a form of vector, in a form of embeddings. Vectors embeddings are actually, vector is a mathematical like a definition wise we say vector. In terms of natural language we say that as a embeddings. Basically numerical representation of any sentence is called as embedding. So those who are getting confused, let me clarify that part, right? So we need a kind of a system, so where I can go, I can try to store those numerical representation. When someone is going to come and query, it should go and check inside that database based on this like distance that we have talked about, right? Like I said, there are different approach of checking these distances, similarities. I'll be talking about that, but as of now just consider we are using only this approach, a childhood approach basically. Obviously it will be able to give me a top result, right? Whichever will be similar to the user query, because even user query we are going to convert it into a numerical representation, then only we will be able to check. So it will be able to give me a top result, and then bingo, means I'm able to retrieve a relevant data from my database as per my customer query. So now I'm able to, or I can imagine a kind of a system which can work even with a NL, natural language. Yes, which can work with a natural language, because in a natural language, I will be able to give a command and I will be able to get a data from my vector DB. Yeah, I'll be able to get a data. So technically, I'm trying to propose this kind of a system. So I will be having a database. I will call that as a vector DB. So where in a form of embeddings, I'm going to store a record. So in a form of, you can say array or embeddings or vector, whatever you would like to say, you can say it. So I will try to store a records. Any number of like a records, I can try to store it. Whenever, let's suppose there is a chat window I have given to my user. So user is going, or I can say that as a client. Yeah, so chat interface may be a mobile application, web application, or anything. So user will come over here, user is going to fire a query, right? User is going to fire a query in their own way, in their own wordings eventually. So let's suppose there will be a query, right? Now this query will be converted into its numerical representation, nothing but it's a embedding, right? Or other word, it will be converted into a vector. Now it will go to this database, it will try to do a matching over here based on a distance. Let's suppose as of now Euclidean distance I have shown you, right? There can be Manhattan, there can be Hamilton distances, there can be a cosine similarity, there can be IP. There are a lot of like distances or similarity check mechanism which is available to me. And then finally, right, finally it is going to give a response which we may try to showcase to a user as a response over here. Are you able to understand this flow? Yeah, why we are doing what we are doing, what was the problem with the a SQL DB. So why we can't store this data into a SQL DB? Why we can't store this data into a NoSQL DB as well? Are you able to get some little bit of understanding, guys? So what is the kind of a problem that we are trying to solve over here? Yes? Okay. Now my next question. Yes? Now my next question. Coming to the next question in the same step. So here we are using a vector DB. That's completely fine. Client is able to send a queries and it is able to give me the responses. Why do we need LLMs then? Or like in this kind of a system, I don't even need LLMs, large language models, maybe ChatGPT model, maybe a Llama model, or maybe Sonnet model. So do we need this model or do we don't even need this model? So what is your thought on that part? How to validate my result from a vector DB? We'll talk about that. Yeah. So Prakash is saying need LLM to score. Okay. Murli is saying LLM validates output of the vector search. No, not a correct answer. Eval framework you have to use. That we'll see what framework we have to use to frame answer into a human readable format. Vinith is saying, and he is absolutely correct. Why? So my question was very simple. Do we need a LLMs? If not, why? If yes, why? LLM means your chat GPT kind of a model. Simple, right? Large language model, any models, basically. So here it is giving me a response, right? It is giving me a response over here. It is giving me a response. Now it will give me a response, maybe which is not suitable, or maybe it is trying to extract a chunk, right? A subset of the data, right? Maybe one line or two line. So which is not particularly, human, which is not going to be a human readable. Means human will not be able to understand. Maybe it is going to be a broken sentence, right? So I need some assistance, basically. I need some assistance. I need some like a, someone so who can try to take this data, because data will come, right? Data will come, obviously. And that too in a natural language itself, it is going to come, right? So it is going to give me a data back in a natural language itself. But I need some assistance over here. I need someone to frame this entire sentence in a beautiful manner. Maybe add some more inputs from their side. If I'm going to command, if I'm going to give a system prompt, right? So I need some system, so which is going to give me output in a beautiful, beautiful manner, which human will see and they will feel happy that, yeah, so it is able to explain me each and everything based on my private data. And this is where I need LLM in between. So this data will go inside a LLM. LLM is going to rephrase those entire things as per the system prompt or user prompt that you are going to configure. And user will be able to see a structured, beautiful, beautiful responses. This is where I need LLMs. If you just have to showcase the output lines, you can avoid this LLMs. That's completely okay in some of the scenario. But yeah, in most of the scenario, you need a intervention of an LLMs, by the way. You need an intervention of the LLMs over here. So what happens that LLM comes into a picture, but not in a straightforward manner, not in this straightforward manner which I have designed. So it will be having little bit different design, I would say. So let me delete this one from here. It will be having a little bit of different design that we say as a RAG. I'll be talking about that. I'll come to that point. But yeah, so here, when LLM comes into a picture, what it does, so let's suppose I'm using a chat GPT model, any model. So over here. So what it does, this LLM is going to take input as a query. So what user has asked actually, this is going to take even output of this vector DB, combine it, right? This is what this LLM does. And then it is going to produce the output. Yeah. Then it is going to produce the output. So technically it is taking input as a query, my LLM, plus whatever output that you are able to get from a vector database as a query, right? As a query to as this particular flow, right? It is going to combine it. Based on that, it is going to reproduce the output and then it is going to give it to you. And eventually it's this technology, this technique is called as retrieval augmented generation. Go to a vector DB, retrieve it, augment it, generate it. Getting my point, everyone? This is called a RAG. So RAG is nothing but user query, means whatever query that you are going to ask, right? Plus output from a vector DB, right? Output from the vector databases. So wherever you are trying to store your embeddings, output from the vector databases. So bring together, pass that as an input inside your LLMs, any large language model. Then this large language model will try to produce the final output, which user will be able to see it. It's called as RAG. So RAG is basically one of the technique that we try to use. So where we have to build a solution based on my own private data, right? My own private data. So I can try to, and in this way, you will be able to build a solution. So where you can try to do a search even with respect to images. There is something called as multi-modal model approach, right? So you will be able to search from the images. You will be able to search from any number of a document, 10,000, 20,000 terabyte, petabyte, or zettabyte of a document in an effective manner. You will be able to solve many problems. And RAG is actually an approach which has been used widely across industry to solve their local problem, because every industry is having a problem. Even we had a problem, right? So let's suppose if I'm building a solution, so where you are supposed to get a response from Euron's private data, Euron's courses, Euron's videos, Euron's services, right? So if you have to get all of those responses, obviously I have to store all of my private data, Euron's data, into a DB. Whenever you are going to query, system is supposed to understand that whether this query is for RAG or direct LLM hit, right? So basically there is a RAG, and there is something called as agentic RAG. So the RAG that you are able to see in our system, that is basically a agentic RAG. We'll come to that point maybe after a couple of months inside your class. We have a agentic RAG approach as well, right? So we are going to explore that particular part as well. But yeah, so as of now, let's talk about a vanilla RAG. So again, inside RAG, there are different approaches that we try to use. So to achieve this, right, to give an answer from your private data, I have to store my data into a vector DB. I have to use LLMs, and then eventually it is going to give me the answer. Why user query is required into a LLMs? So see, if someone has to, let's suppose Preeti, right? Okay. So let's suppose uh, I have asked some question, right? And someone has given an answer. Fine. Now, how you will be, let's suppose you are just aware about, even as a human being, you are just aware about the answer. You are not aware about the question. So, will it be possible for you to judge? Will it be possible for you to summarize that why this answer was given? Yeah. So let's suppose I'm trying to say something, maybe like, so last week, what I have done last week at 12 o'clock night. So I was trying to work on one of the projects, so which was coming from a client, plus I was working into some of the white labeling solution, plus I was working into one of the new Euron offerings, which is nothing but a work and learn. Are you able to understand what I'm talking about? In what context I'm talking about? No, right? Yeah, that's a problem. So if I'll just give you an answer, and if you're not aware about the query, so you will not be able to understand the context, and you will not be able to interpret it. This is where we have to pass query as well as the output from the vector databases. The query is saying, why can't we use other DB to understand sentiments? I mean, yeah, the whole relation basically. Venkat is saying, why can't we use other DB like a NoSQL kind of a database instead of vector DB, as we are converting text into a numerical format? I'm not saying that you can't use other databases. You can use, but I'm looking for a best solution. I'm looking for some solution which will be able to do a distance matching, a similarity matching, right? Similarity matching, which should be very, very fast to do a similarity matching. And that's a core nature of the vector DB. This is not a core nature of SQL or NoSQL database, by the way. Yeah. String based search, yeah, I know this can be done. String based search can be done. Other search can be done, even with respect to NoSQL, even with respect to SQL. But I'm not looking for that. I'm looking for us like a similarity based on the distances of like a two data. That's the reason. So we can't use NoSQL or some SQL kind of a DB. LLM is required only for input prompt writing, or it is also required in response generation? No, actually it's required in a response generation. See, just focus on my drawing, which I have done. Have I integrated LLMs at the time of sending a query to my data? So this is my step number one. This is my step number two. This plus is nothing but plus is my step number three. Plus means combine query and output. Hello, hi sir. VectorDB came into a market only after LLM evolution. Mostly it got a lot of a popularity after a evolution of a LLM. So after 2022 mid, yeah. So basically VectorDB is best at coordinates calculation. As of now, you can say that yes, true, yeah. Can't we put LLM before to refine the queries? No. If you are going to refine a queries, if your LLMs is going to convert a query maybe in some other direction, basically if it is going to change a meaning of like syntactically and semantically, it is supposed to do a search, right? It is based on the user query, it is supposed to extract the exact data. And how LLM will know that how to refine the query and what to do with the query, right? So we try to send our data as it is inside the vector DB. In some of the cases, we try to do a tuning. We try to look for the intervention of this vector database, but not a good approach in most of the cases. Can we extract image also from a vector database? Yes. There is something called as multi-model LLMs. So where it has been trained on images and its captions, and you can do that as well. But for embeddings, we can use LLM. So yeah, for embeddings, so I'm going to talk about that. Yeah. So hope all of you are able to understand the situation over here, guys. So why vector database we are going to talk about. Point number one. Simple definition of RAG, I believe we all are able to understand. Why our conventional DB, SQL or maybe NoSQL DB is not going to work, right? What is a kind of a problem that we are trying to solve over here with the help of vector database, right? Vector database. So, uh, based on that, let's do some sort of a practical. And again, so project wise, I'm going to show you a beautiful, beautiful project. I'm going to even show you a kind of a system. So where you will just write a very, very simple, like a, in a layman way, you're going to write some sort of a sentences. It will go and it will be able to interact with your SQL databases. It will be able to interact with your NoSQL databases. It will write a query automatically. It will be able to fetch a record. I'm also going to show you a system. So where maybe you have a client or maybe you are working into some of the project, which you can directly mention inside your resume. All of these projects, right? So in this vector DB session itself, I'm going to show you, which I have not mentioned in a part of syllabus. I don't mention those projects. But yeah, so I'm going to show you our projects. So where we will be able to build something. So where your user, your customer will be able to chat, your management will be able to chat with any private data out there, and they will be able to get the final responses, right? In a beautiful, beautiful manner. But yeah, that's a core concept behind a vector DB. Now question comes into a picture, right? So everywhere we are talking about converting our sentences into numerical format. Yeah, everywhere, because the entire philosophy, the entire logic that we have discussed, all of this depends upon only one thing. And that one thing is converting my data into a numerical space, into a vectors or as a embeddings. Yes, everyone, can I say that the whole discussion that we have done, it just depends upon only one thing. First of all, convert your data into a numerical representation. Then only you will be able to use it. Priti saying, so context and memory, that's why client input is required. I'm not able to get your context, by the way. Yeah. Okay. Moving back. No. So we have to convert our data into a numerical space. That's a first and foremost requirement we all have. So how we can convert this entire data into a numerical space? I'll show you a very, very simple practical example over here. I'll go to Euron system. I'll go to Uri API. Yeah, we have an API system. And here So we have embedding models. We have a embedding models which is available as a part of URI API ecosystem. What model we have available for embeddings? So let's talk about that as well, right? So for embeddings, if I'm going to click over here, come to API references endpoint, and here, so you will be able to find out that we have a model called as text embedding 3 small. This is a model which is available to me. So what kind of a input you are supposed to pass? So you are supposed to pass basically a sentence, whatever sentence you would like to convert it into a embeddings. And yeah, so your API token and plus obviously the endpoint, right? So API endpoint you have to pass, and in return, right? So if you are using this URL, so in return it is going to give you a numerical representation of a particular data set, right? Of a particular data set. So, okay, let's go quickly and pass some of the data and try to get a embedding, a numerical representation of a particular data. So I'm going to open up a VS Code, or you can open up maybe like any notebook. That's completely fine. Test.ipynb. Yeah, I'm going to use this kernel. Any kernel is going to be fine for me. Okay. Now, so let's do it. So here, I'll go to URI, right? I'll go to URI. This is the curl command which is given to me. So maybe I can try to convert this entire curl command into a Python code. Yeah. Okay. So Python code is available. So I just need this URL, right? So I just need this URL. I can try to pass my token, and I can try to pass my sentence over here, and I can try to, pass my like a model name. So this is the model text embedding 3 small. This is a open AI, one of the most popular, most advanced embedding model, which you will be able to find out in this universe. I'm not saying that this is the only model, but yeah, this is one of the advanced model, which is available to us. So what we are doing, so we are going to pass a sentence. So before that, I have to pass my API token. So what I will do, I'll go to my URI API system. I'll try to create my own API key. So create API key. I believe we all know how to create the API key. I'll be using this API key, and I'll try to replace this with my API token. Let's suppose here, so I don't want this sentence. So I just wanted to write my name is Sudhanshu. Fine. Okay. Fine. So this is my sentence, as you can see. So this is my input, and I'm going to use text embedding 3 a small model, which is available at this URL, this endpoint. We have already we have already inferencing it. And now if I'm going to execute, right? So module name request is not available. So what I will do, I'll just try to write pip install request. So this model will be installed. Okay. So this is installed over here. Now execute once again, and it is hitting my system, it is hitting my URI API. I can even go and I can try to check what was the hit. So I can try to come to logs and I can try to check. So text, which model I have accessed just now in front of you. So this text embedding 3 is small. At this particular endpoint, it was success. Token burn was like a 7 token, completion token, input length is equals to 1. So everything I'm able to see it inside my URI API ecosystem as well, right? That okay. So what was the thing which has happened? What was the duration it has taken? Now, if you will go and check, basically, now let me copy this entire output in a notepad somewhere. What happened? Yeah. Okay, so this is basically a data you are able to get. So embeddings, and this is data, this whole selected data that you are looking at as of now, right? So this whole data is representing one single sentence. Which one? My name is Sudhanshu. The sentence that we have passed over here, the data that you are able to get as an output. So this is going to represent the whole one. Yeah, this is going to represent the whole like a sentence. Maybe I can try to like out of response basically. So out of this response.json, I can try to extract just a embedding part. I believe we all can extract that embedding part, right? But yeah, first of all, do it, guys. Just try to like generate something based on your sentence. Then we'll move next. So anyone who is able to extract, anyone who is able to generate the embeddings, yeah, anyone? Prakhar Singh is saying yes. Siddharth is saying yes. Okay, that's great. Yeah. Now, so let me like try to extract just this embedding out of this data. So there is like some other data which it is giving me as a response. So maybe I can try to store this data. This response, this okay. I'm not looking for this response response dot JSON. Okay, so this is the data. Now response.json I'm trying to like print, and this is the representation. Maybe I can try to store it as a result in a result variable. Yeah. And then just try to parse your JSON, result result of data. Inside that we have what? So we have a data at 0th place. Fine. And inside that, so we have embeddings. Okay. So I'm just doing a dictionary operation, nothing different. So this is the data. This is the embedding. This is the vector representation. I'm able to extract this. And what is the length of this vector, right? So maybe you can go and you can try to check what is a length of this vector. So what is a length? 1536. Now, what is a meaning of this 1536? Any idea, guys? Anyone? What is the meaning of this 1536? Someone is saying chunk. Not at all. Yeah, I think everyone has given me a correct answer except one: dimension. I talked about a dimension, a representation, right? So here I was using two coordinates, only two coordinates to represent one point or one data. Somewhere I was using three coordinates here, right? To represent what? One points or data, three coordinates, x, y, g. And I told you it can be of any coordinate. And as your coordinates will increase, so just to represent one single sentence, how many coordinates do we have? 1536, and you will be able to see a coordinate value as well, right? You will be able to see a coordinate value as well. So this is the actual value. This is the actual value we have. Yeah, this is the actual value of what? This is the actual value of my name is Sudhanshu, right? Now this dimension is not under your control. This dimension depends upon a model that you are using. So here I'm using text small like a 3, text 3 a small model, which is an OpenAI model, one of the advanced one, which has been trained on very huge amount of the data. So this is a dimension of that particular model, and every model again I'll show you in some time, right? So we have so many different kind of embedding models, and every model is going to give you a different dimension. So carefully you have to choose a particular model. It's not like everywhere you will end up using a same model. It depends upon lots of domain use cases or data. So again, a lot of like engineering comes over there in terms of model selection for a only for embeddings. Only for embeddings means a model which will help me out in terms of converting my data. I can even try to create my or fine tune my own embedding model on top of my data. That is also possible. I can try to create my own embedding model from a scratch. That is also possible. And it's not tough. It's very easy actually to create it. But yeah, you need a huge computation and a huge amount of data. In terms of building a model, not a big deal. But yeah, in terms of compute and data, it's actually a big deal. Fine. So this is basically, right? This is basically representing what? So this is technically representing my name is Sudhanshu. Let's suppose I'm going to label it as data A. A means, right? A means my name is Sudhanshu. And this is storing what? This is storing basically that array, right? That vector it is trying to store, let's suppose. Then let's say, let's say I'm going to use a same thing, right? Same thing. And again, I'm going to generate a response. So here, Sudhanshu used to work for Euron, right? Okay. Now it is going to give me a response. So let's suppose I'm going to store it inside not B, so B underscore response, and that is going to be response dot JSON. Fine. Maybe I can try to like okay, here itself I can try to parse. So I can say it as a B. So B is nothing but B is going to represent Sudhanshu used to work for Euron, let's suppose. Let me check. Name response RESPONSC. RESPONSC. Okay. Now let me show you B. So B is nothing but B is the another vector which I have created. Now this is a vector for what? Sudhanshu used to work for Euron. Yeah. Sudhanshu used to work for Euron. Now let me do one more thing. So Sudhanshu used to work for Euron. Now I'm going to generate sentence number C. Yeah. Sentence number C. And I will say, so Rakesh is a Gen AI batch student, right? Rakesh is Gen AI batch student. Execute. So now I have a sentence C. Sentence C is representing, or C basically. C is representing what? So Rakesh is a Gen AI batch student. So I have A comma B comma C. Okay. I have A comma B comma C over here. Now, I'm just trying to re-replicate a same process which I have talked about in theory. This A, B, and C, right? This is something which I have discussed. So I'm just trying to show you the relevancy, that how actually it's relevant. And it's like pretty much practically you can try to understand the exact same thing which I have explained you even in theory, right? So I have a sentence A, vector representation, sentence B, vector representation, sentence C, vector representation. Sentence A means my name is Dhanshu. Sentence B means basically Sudhanshu used to work for Euron. Sentence C means Rakesh is a Gen AI batch student. Yeah. Okay. Now let's suppose I have maybe I have I'll just copy this once again. Yeah. I will copy this one. And here, so I'm going to give input, right? Input as maybe who is or what Sudhanshu does. Yeah, what Sudhanshu does. This is the input, and I'm going to store it as a input. Input, right? INP. In an INP variable, I'm going to store it. Okay. So now I have A comma B comma C, and I have a INP variable. In all this four variable, what I'm trying to store, I'm trying to store a vector of different sentence, right? So hypothetically, let's imagine that this ABC, right? This ABC is available into a vector database. As of now, I have not instantiated any vector database. Let's try to store it, right? So A, B, C is available. Sentence A vector, sentence B vector, sentence C vector is available into a vector DB. Any XYG vector DB. I'm not going to take any name as of now, right? But any vector DB. Now user is going to fire a query, right? User is going to fire a query. So query is nothing but it's available into the INP, because even query will be converted into an embedding. So I have done that. Yeah. Now what it is supposed to do? So now it is supposed to basically like go, right? So now it is supposed to basically go and try to extract, like it is supposed to do some sort of distance matching with A, B, and C. And finally, it is supposed to return me the nearest one, right? Finally, it is supposed to return me the nearest one. Then I can say that whatever I have discussed in theory, so yeah, in a bits and pieces, I'm able to even do it, right? Just by using a normal programming language, Python programming, I'm able to like set those relevancy. So this is my input. Now what I will do, I'll try to find out a Euclidean distance with A, with B, and with C. Can I say that in this so in this is the approach that we have discussed just now? Yeah. Yes. So we can just go ahead and we can try to do a distance matching, right? So we can try to do a distance matching, and then we can try to find out. So how we can do a distance matching? Let me show you that part. That's like a just by not by using any specific library, just by using a raw library. So import numpy as np. So I'm just using a numerical Python library numpy over here. No module name numpy. Okay, cool. Pip install numpy numpy. A basic library, basic Python library that we all know. Then do a import. Fine, numpy is imported. Now here, what we can do, so we can try to, we have A, B, C, right? So we have A. And if I'm going to check what is the type of A, type of basically this A. So type of A is nothing but it's basically a list. So I can try to convert this list into array, right? So that I can try to use numpy method because numpy understands array and matrices, eventually array. So here what I can do, so I can try to like recreate A. So numpy dot array is nothing but A. So I'm trying to pass A and then it is going to convert that into an array. Similarly, for B, so I'm just trying to convert list data type conversion I'm doing, nothing different. So B is equals to numpy dot A double array array and then try to pass B over here. Now C is equals to numpy dot A double array array and C I'm going to pass over here. Input is nothing but numpy dot A double array array and then try to pass input over AY. A double array, A double array. Okay, fine. So here in this manner, I'm able to convert A into a numpy array. Similarly, I'm able to convert B, C, an input variable into a numpy array. So everything is converted into a numpy array. And what is the dimension? 1536, 1536, 1536 because I have used same model, right? I have used same model basically. Now, if I have to find out a distance between input and A, input and B, input and C, I can use again like equivalent distance if I have to find out. So in NumPy, that function is also already available, the root of. You can even do it manually. I don't have any issue, right? But again, that will be tough, right? So this to this, and then square. So that numeric value, that numeric things we already know, right? So if we have two coordinates, for example, if we have like a something like x1, y1, z1, right? And then we have x2, y2, z2. So simple equidistant distance is going to be what? So x1 minus x2 square plus y1 minus y2 square plus z1 minus z2 square, right? This is going to be my equidistant distance between these 2 points. So same thing, we can try to do it with the help of library because our dimension is very, very big, and just see the numbers. Numbers are also very, very big. So manually you will not be able to do a calculation, or maybe it will take ages for you. So I will be using a library. So numpy dot lineage algebra norms. So lineage norms is going to work. Lineage norm norm. And then we have to find out a equidistant distance between what? So we have to find the equidistant distance between maybe input and A. So I can try to make it in this manner. And then I'm going to store it as a distance between INP A. This is the variable INP A. Now similarly, so INP A, similarly, I can try to, create all three distances. So INP and with B, input and C, right? So with V, with C, module numpy has no attribute linear. It should be lineage. LIN linear algebra. So lin ALG. Yeah, that's a module name. My bad. Okay, so distance between input B and input C is this one. Now, let's try to recall everything. Maybe this was very, very quick for most of you, I know, right? Let's try to recall each and everything. So I had a input. Now, what was a input sentence, by the way? What was the input sentence? What Sudhanshu does. Yeah, that was my input sentence. What Sudhanshu does. What was a sentence A? Yeah, my name is Sudhanshu. What was a sentence B? So Sudhanshu used to work for Euron. What was a sentence C? So sentence C was Rakesh is a Euron student. This was a sentence. So my input sentence was what Sudhanshu does. Now, which sentence is closer? Sentence number A, sentence number B, or sentence number C to my input what Sudhanshu does? What? So this was my input. This was my input. And I was trying to do a comparison with A, with B, and with C. So with A, so distance is 0.75. For like a B, distance is 0.85. And for D, sorry, for C, so distance is 1.18. So which sentence is closer to my input? Yeah, which sentence is closer to my input. So it looks like that this is the minimum distance, right? This is a minimum distance. And what was this sentence A? So sentence A was my name is Sudhanshu. What was sentence B? Sudhanshu work for Euron. And what was our sentence number C? Sentence number C was Rakesh is Gen AI student. Yeah, so based on Euclidean distance, it is telling me that the data that you have, like the data input that you are trying to give basically, so this is having the lesser distances. This is having basically a lesser distances as compared to, so this is 0.75, this is 0.85, and this is 1.18. So the highest distance is this one, and I think it's true, it's justified. It is nowhere we have a Sudhanshu over here, right? Nowhere we have a Sudhanshu over here. Sentence B and C, so many of you will say that that sentence B should be, or ideally it should be more closer to our input, and it should, like this distance was supposed to be lesser as compared to this distances. Yeah, many of you can come and argue, but yeah, there will be a answer for that. That first of all, take a bigger sentence, create an overlap in between. So basically we call it as a chucking, we call it as a overlapping, and then our sentence was very, very small, right? Very small means literally very, very small. I mean like 2 3 words, right? So and again, so our embedding size is 1536. So we are using this number of dimension to represent every sentence, A, B, C, and input even, right? So obviously if our sentence is not that explanatory, but it's working, right? Another part is we have done a Euclidean distance, which is one of the I can say a novice approach, right? To check our distances, maybe I can try to use something different, cosine similarity, maybe IP, maybe hybrid. I can try to do hybrid search. So that is going to give me exact result B, which I am expecting as a human being, not as a machine, right? Maybe as a human being. So whatever I'm expecting, it is like going to give it to me. But I think this looks interesting, right? In terms of doing a matching. Yeah, this looks interesting. So we are able to do a matching. So whenever user is going to give an input, these three sentences will be available in vector database, right? Inside a vector databases, this things will be available. And eventually what I will do, so I'll try to pass an input. It will go to vector DB, try to check based on some distance mechanism, right? Maybe hybrid, maybe IP, maybe like a cosine similarity, maybe Euclidean, maybe Manhattan, whatever I'm going to configure over there, it will try to bring relevant data. Yeah. What formula is used to convert text into embeddings? Prakash, I think you should focus more on class. We have not used any formula over here. We have used a model. This is where like a URI API comes into picture, right? I've used 4 times in this lecture itself. How to refresh a data in a vector database when SQL database frequently changing, require a schedule job insert. Only will come to those part. Yeah, I think we are in a very early stage. So once we'll come to those part, you can raise those questions and I'll be happy to answer your question, but not now. We are trying to understand the uses of vector DB now. That why we are even talking about vector DB. What will be the actual use of the vector DB? How can we validate the output from the vector DB? That also will come into picture. Yeah. So wait, not everything on a single day, not possible. Yeah. So everything I'll discuss one by one, one by one. We'll keep on like building a stories basically. So one story after another story. Okay. So hope this idea is clear, guys. So what is a meaning of a vectorization? First of all, what is the use of a vector DB without even using a vector DB? So far, I have not used any vector database, by the way, right? How we can convert our data into an embeddings? Basically, what is a meaning of a embeddings? What is the meaning of eventually a vector? What is the meaning of the embedding? Which model we are using over here for doing a embedding? Right? So everything we are able to understand. Now, you all can try this out. URI API is already available. I have just used URI API. I have not used anything different, right? Anything different over here. So anyhow, this file will be available inside your dashboard, by the way. But yeah, so whatever in theory I was trying to talk about, so I'm able to prove that point. So with the same approach, exact same approach, equivalent distances, right? Okay, looks great and cool. Now, embedding model wise, right? Embedding model wise, so we are trying to use this OpenAI text small 3 model, but you can try to use basically other embedding models as well. There are so many other models which is available. So here, if I'll go to Hugging Face, which is one of the biggest open source repository for any open source models, right? Even like a proprietary one, but with a price charges, embeddings. Now, if you are going to search for embedding, it is going to give you so many results, right? It is going to give you so many results. So it is going to give you, yeah. So it is going to give you a Quen embedding, KLM, Gina embedding, and then there are like a 3,461 model alone available inside Hugging Face just for one task. Convert your data into a numerical space. So out of this 3,461 model, as of now, as of today, you can try to use any of this model, but not all model is going to fulfill the need, fulfill the purpose, right? So for example, from Google also, embedding gamma is available. So with like a 300 million parameter, Quen embedding with zero point 0.6 billion parameter, Gina, so Quen again with 8 billion parameter. So all of these models are available inside a Hugging Face. The way we have used, and again, everyone is going to do the same thing, right? Everyone is going to do the same thing. Now, whenever you are going to use any of this model, so first of all, try to check the data, right? That on which data it has been actually trained. People are going to mention, people are going to mention each and everything about that model. So whenever anyone is going to release the model, so they release a proper documentation as well, that what kind of a data which is been used to train this particular model, what is input dimension. So for example, output dimension is 768, in our cases 1536, right? So this is going to give you whatever input you are going to give, this is going to give you return in a 768 vector space. So all of these details documentation will be given to you, and the way I will be able to use one model, in the similar manner I will be able to use all 3,461 model. It's not going to be different, but I have to choose first, right? I have to choose first. So for example, if I'm trying to solve some problem for a HR department, so maybe I have to use such kind of a model. It will be better to use such kind of a model which has seen more HR related data. Let's suppose if I'm working on a clinical research, so I have to use a kind of a model, so which is been trained on a clinical research kind of a data, because embedding is what? A numerical representation. Now numerical representation means what? Semantic and syntactic relation consolidation. Yeah. So this is where like we'll be using so many things, right? So many like different model we'll be using for different data for different use cases. But yeah, I just wanted to show you that it's not just one inside Yuri. So let's suppose if you don't want to use from Hugging Face, inside a Yuri you have a best model available for embeddings, and that has been trained on a very huge generalized data, right? And you have a enough token limit as well, so that you will be able to convert a huge amount of a data into its embedding, and then even you can try to call a LLM on top of it. But for today, I think we should stop our discussion. So you should also like you all should look into this lecture once again, maybe try to digest it, right? Maybe come up with the questions that you have in your mind. We'll take some question today also, right? Come up with a question, and yeah. So yeah, I think you all should take some time to digest. Fine. Uh, because for many of us it's going to be new, but it's very important for next 5 to 6 class. Unless and until we are not going to build a production grade application and we are not going to push it into a cloud, right, which will be publicly available, we will keep on discussing this, right? We'll keep on discussing this, and even further lecture will depends upon such kind of a concepts. So for a particular task, we must use a single model. That's true. So the distance, yes. So if you are using a model, some model for converting your data into an embedding, which I'll show you again and again and again many times, same model you are supposed to use even at the time of querying. Yeah. What is meant by 300 billion, 400 billion etc parameter mentioned with the model name? So this is 300, 400 billion parameter is simply means that that many number of the weight and weight plus biases value it has been trained on. And whenever you will try to do like inferencing, means you will be looking for an output, it will go through that many weights and biases, and then it will try to do a calculation, do a math, and then you will be able to get your final output. That is the meaning of number of parameter. It's number of trainable parameter. Can we put a embedding from a different model like OpenAI embedding? OpenAI embedding itself I was using, by the way. So OpenAI embedding, we have given you an access inside a Yuri API system. So this small 3 model that I have shown you, so this text embedding is small 3 model. You can go and check on Google. It's actually a OpenAI model, and that is one of the best model, and we have given you access. Yeah, if you would like to like burn your own money and token, right? So obviously like we are not the only provider, so even from a OpenAI portal itself you can create a API key and then you can use it. Even from maybe Amazon Bedrock, you can go and you can try to access those. That's okay, that's completely fine. But model wise you will be able to get exact same model, not different one. Model means API like Yuri, Google API. No, that is not a meaning of model. I think guys, like some of you are not, I can see that some of you are not good with a basic like things. I'll strongly recommend you to go through my FSDS lectures in your free time. Believe me, that is going to build a base in such a way that you will be able to understand everything without even my help in future. I'm talking about after 2 year, 3 year. Yeah. And without reinvesting your time and money in learning and upskilling. Yeah, that's a strongly like advisable to all of you. If different example sentence were used, the result would have been more accurate. Yes, obviously, because everything is getting converted into a like a numeric value. But yeah, most of you even, will be able to understand even all those concepts. So that's the reason. So I'm just telling you, go home, sit peacefully, and then try to digest all of these concepts. Now it's time to take a couple of questions. So please raise your hand, guys, so that I can like unmute you and then you can ask a question. Yeah. So Soumya, go ahead. Then Kunal, go ahead with the question. And if anyone is having question, raise your hand, please. I had a different question. Can embedding generates from a different model, OpenAI embedding and AWS Titan embeddings, be stored in the same vector databases? Yes, exactly. You can use any model to convert any data into an embeddings, which I'll show you. You can use any vector DB to store those embeddings in that vector DB. So I can use Quadrant, I can use Pinecone, I can use maybe a Chroma, I can use a Farsi, I can use a Postgres vector DB. I can use even a MongoDB based vector DB, right? So there won't be any kind of a limitation. I can use any model at any end from any provider, any vendor. But yeah, so when I say model selection, obviously we have to keep our domain and data in mind for doing a model selection. Okay. So yes, question please. Kunal, go ahead.
Hello.
Yeah,
So
Kunal.
my basic question was, for a use case, can we use multiple embedding models? Like if we don't want to exhaust the token limit and then
Not at all. Not at all. So you are not supposed to use a multiple embedding model. So whatever embedding model you have used at the time of storage of the data, same embedding model you have to use to query into that data. If your data
yeah.
set itself is different, your DB itself is different, right? Then obviously you can try to use change the model. But for a same data and you are filing a query on the same data, same embedding model is
No,
supposed to be used.
yeah. Like if we are creating a chatbot and there are some questions related to HR and
Hmm.
some questions are related to product, in-house product which we are developing.
Hmm. Hmm.
So for HR, we are using different embedding model, and for product, we are
Okay, no,
using,
Kunal. Yeah, yeah. This is what I was trying to say, that if your DB itself is different, right? If you are storing everything into a separate DB, then it's isolated.
yeah.
You can create one pipeline for HR, one pipeline for sales, one pipeline for other department. It's your wish. Yes, and that can be done. So in that situation, you can use one different model for a HR, one different model for a sales, one different model for some other department. So in that way, you can use hundreds of different embedding models for a different pipelines.
And as you said, there are like multiple models on Hugging Face. So filter them out. What parameters shall we look
First
into
of
them?
all, a domain. First of all, you have to check that on what kind of a data this particular model was trained.
Okay.
Yeah, that's a very first parameter. That's a very first criteria that you have to check. And then obviously, like embedding length, it should not be too small. It should not be too big because it is going to increase a complexity of the calculation in terms of doing a similarity search, basically.
So
So that is
mostly it is try and error based up to like,
not a trial and error base. So on a very first day, I have already given an example. For example, if I'm trying to solve something for HR, right? I will try to go and select a model so which is been trained on that kind of a data which is there inside my HR. Not an exact one, a similar to that, right? For example, if I'm working in a clinical research, right, or maybe some healthcare like a kind of a situation, so I have to pick and choose a model which has been actually trained on those kind of a data. So it's not going to be trial and error, by the way.
yeah. Okay. Thank you.
Yeah. Yeah. Okay. Next one is yeah. Rakesh, go ahead, please.
Yeah, hi sir.
Yeah.
I wanted to ask two questions. One
Hmm.
is for related to embedding models and the model which is using a more dimension. Is it we can say it's a perfect model for
No, it's not like that. So any dimension between like a 600, 700 to 1500 or maybe 2000. So all of these things are good. Basically, more dimension means more representation. So more detailed representation we can say. But that doesn't mean that more dimension means better embedding. So I
okay.
always advise and suggest that whenever you are trying to pick and choose some embedding models, go
Hmm.
after the data which has been used to train that model and the data
Okay.
that you have in your hand.
Hmm. Okay, okay, understood. And the second question is, suppose we in our organizations there are lots of data is storing in a SQL DB and in some document, and then if I want to implement our LLM, so can we go for all the RDBMS data? I mean, a SQL database, all the data go through the embedding, and we can store all those data in vector DB, or it's a better to some data goes in a vector DB, some data goes in the RDBMS, and we can
That
give the
that
answer
depends.
according.
There is no generic answer for that, I would say. So that depends upon the problem in hand. So what problem we are solving, then only we can design the solution. We can't say that dump all the data into vector DB or keep something here, keep
Hmm.
something there. That
Okay.
always depends upon the system design that we are going to do for a particular problem. So it's case to case basis.
Yes, yes, because of lots of data we have already stored in the SQL DB, so it's not a good way to, I mean,
I mean,
convert
like,
all
there is
those
nothing
data.
called as good way or bad way. It's a
Mhm.
problem and a solution. So I never consider anything as a good or bad. So when
Mhm.
you talk about your specific problem, accordingly, we design the specific architecture. This is how we solve, like look into the actual like a problem and solutions basically.
Okay. So is it also possible to converting our the RDBMS data into a vector DB?
We can convert anything into vector DB
Hmm.
because it's just like a chunk we need, right? A data we need. We can
Yeah,
pass those data.
understood. But
Yeah.
I just wanted, sir,
But how we are converting it, which column we are considering it, why we are considering it, what is the use case in hand, all these things matters a lot. It's not like blindly you will pick one row and convert into a vector DB, then second row vector
Right.
DB.
Because see, that's why I'm just thinking, because in the tabular format, somewhere we can store I mean the product unit of the development, and somewhere we can store the rupees and something. So how it related to, because it's a numeric value only
Yeah, yeah.
within
That's
within
the
a one
reason
column.
that's the reason I told you precisely that it depends
Understood.
upon the problem in hand, right? So if there is like a not a thumb rule that we can apply everywhere and we say, okay, just do this. No, that is not going to happen. Otherwise, everyone would have used the same approach,
Yeah, right.
and in that case, Gen AI engineer is not required. So because everyone can
Understood.
replicate the same template, right?
Understood.
Yeah,
Got it.
yeah,
Thank you.
yeah. Thanks. Okay, next is Soham Rajput. Go ahead with the question.
Yeah, hi, Sloan, sir.
Yeah,
So
go ahead,
my
please.
question is like for the images kind of data. So I mean, this is my assumption for that the number of dimensions should be on the higher side if we just take store that in the vector database, correct? Because those are having more complicated data points in images, the pixels and all this in compared to the textual data. So
Uh,
obviously the number of dimensions, as you told, it should be 600 to 1500 range. So it should be every time should be on the higher side for images and video kind of data.
So video is
Yeah,
nothing but it's a frame. It's actually an image. So video is nothing different. So it's actually an images. Obviously, it should be in a higher side of it. And there is something called as a multi-model system. So that is something that we are going to use over there.
Yeah. Okay. And second question is, Sudhanshu sir, like, basically, when we are storing some PDF files into vector database, okay. So suppose at the time of production, like some PDF files are getting updated. So like for HR policies and insurance policies are getting updated with some span of time. So how should we build this pipeline? Like, should we keep on updating that? Like how we can update this rack pipeline? Sorry, this pipeline which you told. So is that to be a one-time process?
Just like any normal database, right? So whenever new data will come, obviously you are going to do a insert operation, right? You will even update operation. You will even do a delete operation with respect to the data which is the old one, right? So in the
Mhm.
similar manner, so even vector DB is a DB at the end of the day, right? So
So it's a
whenever I
one-time
will
activity we can do.
Yeah, so basically, I will be able to do a insert operation, update operation on the particular indexes. Even I will be able to do a deletion operation over there, and everything we are going to do it in a class also.
Okay, sir. Thank you.
Yeah, yeah. Okay, Venkatesh, please go ahead with the question.
Yeah, continuing to the previous conversation,
Mhm.
how security of our vector DB, I mean, regarding our
Security,
data.
yeah. So security depends upon the multiple factor, not just on one factor. The very first factor is where you are hosting your vector database. So let's suppose if I'm trying to host it somewhere on a EC2 instances, so obviously I can try to allow a traffic, I can try to disallow the traffic, I can try to add a certificate over there, I can try to add a auth layer on top of that. So this is where we try to maintain and manage the security. Simple.
Can we do the CRUD operations on top of the vector DB?
Not a curd, I mean, like, not a curd operation in a conventional way that we do, but we'll see how we query the vector DB very soon. I think in a tomorrow's class itself.
Okay,
Yeah.
thank you.
Yeah. So Anna Murthy, please go ahead with the question.
Yeah. So Anand here.
Yeah. Sorry, Anand. Sorry. Yeah. Yes, it's Anand Murthy. Sorry, my
Yeah,
bad.
it's okay. So
Yeah.
I have two, I have missed two of the classes like last week, but I was not able to see the.
No, actually, last week, so because of family emergency, I have not taken the class. So you have not missed it. Uh, Basically, I
Okay.
have not taken, and I have also updated in your group. So if you're a part of group, if you're not a part of group, so please join your WhatsApp group for your class.
Sure. My bad,
Because
my bad.
yeah, because and link is already available in a very first like a lecture, right? So link is
Sure.
available, and I will keep on updating over there, and I update before. Like, let's suppose if I'm canceling class tomorrow, I'll update you today itself, so that you can plan anything according to
Accordingly,
that.
yeah,
Yeah,
definitely.
yeah.
One more thing, Sudan. So I won't take much of your time.
No, no, it's fine. Yeah. Mm.
So the thing is, like, it's regarding the consultancy thing. when we had last conversation about that, like you were telling that no matter what kind of machine learning is there, but
Hmm.
machine learning, like it can obviously be solved by the generative AI and the deep learning things, but under the what do you call, the constraints that they have allowed us to follow, is just that we can't use any kind of accelerators on uh, these Kaggle, and we have to use the basic DL, like machine learning, like using the
Kaggle, I'm not able to get why Kaggle is coming into picture. So
the consultation thing, like the student package. So
which
so
one? Which one? The package that we have here
yeah, yeah.
on
Like,
Euron. Okay. So what
so
is the
I just
question?
wanted to confirm before I go and complete my transaction.
No. So
So
yeah, what is your question? I'm not able to get it actually. Yeah. So if you can reiterate,
so so
there is a
in the
consultancy. Yeah.
yeah, yeah, in that one there is one thing which is related to student, yeah, silver
Hmm.
one, yeah. So
Silver
in
package, student
this,
pack basically. Yeah.
so you were telling that no matter what kind of project is there, but
Hmm.
the project which we have been given is kind of restricted kind of thing.
Hmm.
So we have to do that only on the Kaggle, and we can't use any type of accelerator which is available over there. So
So is it a requirement which has been like given from your college? You are in college by the way?
no, no, no. I'm not in college. I'm doing uh, a direct diploma kind of thing from IIT. So
Okay, fine. And from there, so they told you that in a Kaggle
yeah,
itself, you have to do it, right?
yeah, yeah. And continuously they have been reducing the R square value. So the data set
Got
is
it, got
quite
it, got
lovely.
it,
Yeah.
got it.
So
So it is actually supposed to be done inside Kaggle. This is what you are saying.
yeah,
So
yeah,
basically, it is supposed to be submitted in your Kaggle account, basically through
yeah,
your
yeah,
Kaggle account.
yeah.
That's the whole idea, right?
So is it good to go ahead?
Then it's fine. Like and what is like? Is it a complex project? How is it?
Like it is a complex project because the R square value which they have reduced is point three,
Okay,
yeah,
okay.
0.32.
Mm-hmm. Fine.
So
That we can see like after looking into the relationship with the data, that can be
okay.
reduced further by like taking some approach of a hyperparameter or maybe like a range
Yeah,
of.
yeah, parameter tuning I was trying to do, but like you know how, like I,
Got
I
it,
I
got
tried
it.
doing the
We'll
cache
do
and
it.
everything. Yeah.
Go with gold then. That you will be secure for 6 months at least. Yeah.
Yeah,
And
that will
uh,
be the more better thing to do. Okay.
exactly, yeah, and we'll do it in your environment. See, this
Okay.
is where consultancy comes into picture. Consultancy simply means that you bring a requirement with your problem statement, your environment, your data, whatever you want, we will do it because we'll treat you as a client. Simple.
Okay. Okay.
And we have launched this work and learn as well. So work and learn means you pay to us and then you work with us.
Okay. That will be a better thing to do.
Yeah.
Okay. Okay. Okay.
So they
Okay.
were like a two offering that way. Walk and learn. I will be talking about in your class tomorrow. I have not discussed. I've discussed about that in my morning class, but yeah, not in your class. But yeah, I
Sure.
think we all are aware about consultancy. So bring your project. We have a white label. If you would like to launch your edutech, if you would like to launch your URI or LLM with additional feature, anything, right? Give it to us. We'll do it. We'll deliver it for you. If you're launching
Sure.
a startup, not an issue at all. Ask us to build any kind of app, not just a AI application, any
Mhm.
other application, and we are going to build it for you.
That's good. That's great. Okay. Thanks, Sudhanshu. Thank
Yeah.
you.
Okay.
Thank
Thank
you.
you. Thank
Yeah.
you. Yeah. Imtiaz, can you please show again where the codes of Iran site shown? Okay, so Imtiaz, basically you can go to this Euron, and then there is a URI API, as you can see. Sorry, I think I'm not sharing my screen by the way. Yeah, so you can go to Euron Imtiaz, and then from there, so you can go to URI API, and then here, so you will be able to find out the endpoints. Yeah, endpoint. Click over there, and then click over there. This is basically like for chat completion. This is for embedding. So curl is given to you, so technically, as per my discussion about an API, and I believe we all understands API, we need what? We need a endpoints. We need a input data. That's it. So hit any API. So hit it. This is what I have done. Astos is saying input model should be same for input and output for one single pipeline. It is supposed to be same. Yes. Vector database runs locally. We are going to run it locally as well as we are going to use a managed services. So we are going to use both the services. So hopefully, guys, all of us are able to understand something about a vector database, something about this embeddings, something about using some of the pre-built model for embeddings. So tomorrow again we are going to continue with the same lecture, and we will try to introduce a vector DB. So we'll try to store our data into a vector database, and then we'll try to do a lot of like operations. Plus we are going to introduce a lot of search operation as well. For example, a cosine similarity or hybrid search, right? All those things we'll be talking about in my tomorrow's class. So with that, guys, thank you so much. Take care, and see you again tomorrow, same time. Yeah, thank you.